In this lesson, we're going to talk about something called the geometric mean. Now, you've seen the word mean before, and in previous cases, it meant the average. So if we said, find the mean between 4 and 16, you would do 4 plus 16 divided by 2 and find out that that average is 10. This is called the arithmetic mean because the arithmetic mean is that number in the middle where I have to add something to 4 to get to this number, and then I add the same thing again to get to 16. And this number in here would end up being 10. 4 plus 6 is 10. 10 plus 6 is 16. So the mean that we're used to talking about is actually the arithmetic mean, because we're adding the same number to get to the next number. So now we're going to talk about this thing called the geometric mean. The geometric mean is the number in the middle, but this time we're going to multiply by something to get to the next number. So we need a number here in the middle where I multiply to get to this number, and then I multiply by the same thing to get to the next number. So you might be able to figure out that this number is actually 8. 4 times 2 is 8. 8 times 2 is 16. So how do we come up with that answer if it's not something quite this easy to see? So here's the definition for the geometric mean. If x is the geometric mean between a and b, then here's a little formula for us. A over x equals x over b. So when I multiply this out, notice what's going to happen. I'm going to get x squared equals a times b. And then once I get this, I'm going to take the square root of both sides and get x equals the square root of a times b. And then we'll use our radical magic to simplify whatever's inside here. So basically, we're going to multiply the two numbers and take the square root, whereas for the arithmetic mean, we added and divided by 2. So you can see the differences in the operations that we use. So this lesson is about the geometric mean. We're not finding the arithmetic mean, the average. We're finding the geometric mean. And here's our process. Notice the geometric mean is the number that goes across from itself. That number gets listed across from itself. So for example, find the geometric mean between 4 and 9. So I'm going to say 4 over x equals x over 9. Just following my formula. When I cross multiply here, I get x squared equals 36. And take the square root of both sides. I find out that the geometric mean is 6. Now in this case, we're not talking about, because when we take the square root of 36, we can get a negative 6. In this case, we're talking about the principal square root. So we'll just take the positive 6. Especially in geometry, when we're doing our shapes, we can't have negative lengths. So we're always going to take the positive. All right, next up, find the geometric mean between 2 root 5 and 4 root 5. So we set up our equation. 2 root 5 over x equals x over 4 root 5. Now we multiply these together. X times x is x squared. Then 2 root 5 times 4 root 5. 2 times 4 is 8. Root 5 times root 5 is 5. So x squared equals 40. Then we take the square root of both sides, and the square root of 40 simplifies into 2 square root of 10. So 2 square root of 10 is the geometric mean between these two numbers. All right, next up is 5 and 10. So 5 over x equals x over 10. We multiply. X squared equals 50. Take the square root of both sides, and then we break down the square root of 50 into 5 square root of 2. So there is our geometric mean between 5 and 10. Now, what does this have to do with geometry? You're probably wondering. That looks like algebra. Well, we take a picture like this one that has this right triangle, ABC, and it has this segment BD right there, which is an altitude. So notice it makes a right angle with the opposite side. That's what an altitude does. But what happens with this picture, hopefully you're looking at it, how many triangles do you see? Well, I see a big one, ABC. I see another one, ABD, and a third one, BDC. So I see 3 triangles. And because this is a right triangle with an altitude, that's going to be important. Right triangle with an altitude, not with an attitude. It's not a teenager yet, just got an altitude. This creates 3 similar triangles. So there's a little direction over here. Name 3 similar triangles. Well, I'm going to help you illustrate that. Well, first off, we take our big triangle, and then I have a little triangle here, and the other triangle is here. It's going to take a little finagling to make this happen. So if I pull this apart, they've told me I have 3 similar triangles. I'm going to start with ABC. And the next one I'm going to pull up here is BDC, and then ADB. And they do kind of all look similar to each other. And we can check those out because we know that there's a altitude that goes from B to D right here. So this angle A is congruent to this angle A. This angle C is congruent to this angle C. Then how about angle B? Remember angle B got cut into 2 parts? So this angle B right here is the same as this angle C. This piece right here is going to be congruent to angle C. Because see, there's a right angle, there's an angle A, and here there's a right angle and angle A, so B and C must be the same. And then this piece right here, this other side of angle B, is the same as angle A. Okay, I know that's a little bit confusing. So here's how we're going to look at it. When we look at these 3 pictures, we have some ratios that we're going to use. Because remember, similar triangles, we can write ratios to find missing sides. So what happens here, let me go ahead and write these out. Triangle ABC is similar to triangle BDC. I just said it and wrote it wrong. BDC, and that's similar to triangle ADB. So if we needed to name the similar triangles, we can do that. So what it took to accomplish that, let me go back through that again. Here's the little triangle, here's the other triangle. So the way I made these look like they were similar to each other, I took this triangle, and when I flipped it over, I matched the right angle. Then I took this triangle out. I had to flip it over too to make them all match. Now, here's the fun part. Some of these segments in the picture are geometric means. That's why we just did all that previous stuff. So here it says BD is the geometric mean between AD and DC. So look right here. We have segment BD. So notice in the orange triangle, BD is the vertical leg. But over here in the yellow triangle, BD is the horizontal leg. I'm going to call BD a double agent. Sometimes he's the left leg, sometimes he's the bottom leg. He's a leg in both triangles, but he's a different leg. So he's like secret agent man. So what we would write for that one, BD, is going to be my geometric mean. So if I said, I call this one, by the way, leg over leg. So if I said leg BD And I'm going to compare that to leg AD, because see how they're the same, the left side over the left side. And then I'm going to go, let's see, I went this way, AD to BD, then I'm going to go BD to DC. And I'll show you what that looks like in the big picture here. So this is the one I call leg. BD is a leg, but it's a leg in two different triangles. So over here, I'm going to call it H because it's kind of the height of the triangle. This is the geometric mean between AD and DC. Now some people teach that one, they call it the heartbeat, because it's kind of like that heartbeat you see on a monitor where it goes AD to BD, BD to DC. We can see it clearly when we turn the triangle sideways, but in the big picture, BD is a leg, but it's a different leg in these two triangles. So BD is our first double agent. That altitude is the first double agent we have. Now we have AB. AB over here is the geometric mean between AD and DC. So notice AB in the big triangle, it's a leg. But go over here to the yellow triangle, and what's AB now? It's a hypotenuse. So I call this one leg hypotenuse. So we're looking at AB. Sometimes it's a leg, sometimes it's a hypotenuse. So he's our double agent. So we're going to write our proportion using AB. So I'm going to start over here with AD because it matches. AD over AB. So that was leg over leg. And now we're switching to hypotenuse. AB is the hypotenuse, and AC is the hypotenuse over here. So we're using AB as our double agent. Sometimes it's a leg, sometimes it's a hypotenuse. So when you look over here, AB, what did I call it? X. So in this little triangle, we did leg, hypotenuse. Then we switched to the big triangle and we said leg and then hypotenuse. So we started with the little triangle. Leg over hypotenuse. We switched to the big triangle. Leg over hypotenuse. So AB is also a double agent. Make a mark there. All right, next up, BC is our final double agent. So look in the big triangle. BC is another leg. But look in the orange triangle. Now BC is a hypotenuse. So double agent. He's a leg, he's a hypotenuse. So we're going to do the exact same thing we did with AB. So I'm going to start with leg over hypotenuse. Or I could do leg over leg. Let's see. Where are we? Let's start with DC to BC. So that's leg over leg. So DC and BC. And then I'll go to hypotenuse over hypotenuse. BC over AC. So when I look at the big picture, BC is right here. BC is my leg, or it's a leg of the big triangle. So here we go. In the little triangle, leg, DC is the leg, BC is the hypotenuse. So I leg over hypotenuse. Then I go to the big triangle. BC is a leg, AC is a hypotenuse. So those are the three rules you need to know. There's leg, which is this one in the middle, and the other two are leg, hypotenuse. You take the little triangle, leg, hypotenuse, then you take the big triangle, leg, hypotenuse, realizing that BC is in both triangles. So let's take a minute and see how this is going to work when we practice. So we'll put these rules into practice with these examples and see how it works. So in the first example, okay, if you look, you'll notice that 18 is in the double agent position. It's a leg in this triangle, and then it's a leg in this triangle. So we're going to use our leg rule. So let's take this triangle on the left, and we'll do leg over leg, 12 over 18. And then we'll take the triangle on this side, and we'll do leg over leg, 18 over y. So how did I know to do 18 over y instead of y over 18? Well, 18 was the double agent. He's a leg in both triangles, but he's a different leg. So once on the bottom, once on the top. And when I solve this, let's see, what's 18 times 18? Grab my calculator. 324. And then divide that by 12. My answer is y equals 27. So 18, it turns out, is the geometric mean between 12 and 27. That's our missing side. All right, let's do the next one. Notice again, this side right here is our double agent. It's going to get listed twice, once on the bottom, once on the top. So if you want to, you could just do that. So we take the left side, leg over leg, 5 over y. Then we take the right side, leg over leg, y over 8. We multiply it out and get y squared equals 40. So the square root of 40 is going to break down to be 2 root 10. All right, let's do another one. Again, this is practicing the leg rule, because we've got this altitude right down the middle. That's our double agent. So we're going to take the left side, leg over leg, g plus 5 over 12. And we take our right side, leg over leg, 12 over 18. And now we just multiply. 12 times 12 is 144. 18 times g plus 5 is 18g plus 90. And then we subtract the 90 and get 18g equals 54. We divide by 18 and g equals 3. So there we have it. So that's an example of the leg over leg rule for geometric mean. All right, let's see if we have some other examples. The leg over leg rule applies when you need this altitude segment. Everything else is going to be the leg over hypotenuse. So on this one, I'm going to highlight this x right here because it's going to be the geometric mean. So remember this, it's a leg in the big triangle. It's a hypotenuse in the little triangle. So this one's going to be leg over hypotenuse. So let's take this little triangle and we're going to list leg over hypotenuse. 5 is a leg, x is the hypotenuse. Now look at the entire triangle. X is a leg and my hypotenuse is those two put together, which is 9. Okay? Leg over hypotenuse, big picture, leg over hypotenuse. And we solve it, x squared equals 45. So the square root of 45 breaks down to be 3 times the square root of 5. And there is our missing piece. All right, same thing over here. In this picture, I know it's leg hypotenuse because they're not asking anything about this altitude in the middle. So I'm going to highlight this side, this leg over here. Remember, he's a leg, he's a hypotenuse. So we're going to do leg over hypotenuse. So take the little triangle and let's list the leg over the hypotenuse, 16 over 27. And then we'll look at the big triangle where 27 is a leg and z is the hypotenuse. Leg over hypotenuse. And then we solve it from there. So 27 times 27 is 729. And 16 times z is 16z. I don't think this is going to work. This is going to turn out to be a whole number this time. It is not a whole number. So what are we going to do? Well, this is the exact answer if you keep all of these decimal places. Or usually we round it off to the nearest thousandth. It all depends on what the directions say. So I'll just go ahead and write the whole thing. 5625. So you could have also, like I said, depending on the directions, to the nearest thousandth would be 563. So there we go. All right, we have another. Again, if they're asking us about this line in the middle, that's leg over leg. This is leg over hypotenuse. So we'll take it in pieces. In this triangle, I don't know this side, do I? Let's look again. The whole thing is 8, and that part's 2, so guess what this one is? So now I can do it. Leg over hypotenuse, 6 over x. And now big triangle, leg over hypotenuse, x over 8. So we multiply, x squared equals 48. So we're going to simplify the square root of 48. If you wanted to go 4 times 12, and then 12 is 4 times 3, you get 4 square root of 3. Alrighty. Now in these last couple of pictures, they want us to find everything in the picture. Now I'll be completely honest with you. You can use one of these similar triangle rules, either the leg over leg or the leg over hypotenuse, to find one side and then Pythagorean theorem the rest of the picture. But I'm going to let you do that if you're taking a test or just doing your practice. But for this, I'm going to use the new rules just for extra practice. But just know that once you find one of the missing sides, you can do Pythagorean theorem to find everything else. So on this one, because it looks like an easy one to do, I'm going to start right here and find x. So remember, x was the geometric mean. That was leg over leg. So, and it was also the one called the heartbeat. Remember, we did this up here, back down, and over 3 over x, x over 15. Leg over leg, leg over leg. So x squared equals 45. And part of me is thinking I just did this. There it is. I just did that one. So x is 3 root 5. Now there's two ways we could approach everything else. You could do the Pythagorean theorem from here. This squared plus this squared equals z squared, and the same thing over here. But just for practice, because we learned these new rules, I'm going to use the new rules. So I'm going to find y next. I'll highlight y because he was my double agent. So he was leg over hypotenuse. So look at one triangle. Leg over hypotenuse, 3 over y. Now look at the big picture. Y is now a leg, and the hypotenuse is 18 all the way across. So y over 18. And then we solve. Y squared equals 54. So I'm going to simplify the square root of 54, which is 9 times 6. There we go. 3 root 6 for the value of y. Now remember, you could have done the Pythagorean theorem, 3 squared plus 3 root 5 squared. Let me just warn you, if you're going to do that, be really careful. If you're going to do 3 squared plus 3 root, whoops, let's got to put something inside the square root first. 3 root 5 squared. See what I did? I made sure my 3 root 5 was completely in the parentheses before I hit the squared. I get 54. And the square root of 54 simplifies. And if you forget to do that, it's going to mess things up. So if I did this and squared it, see how that looks completely different? And I get a number that's completely different. So if you're going to do Pythagorean theorem, make sure you close your parentheses before you put the squared. Just a warning. And let's do the z. Again, z is it's a leg, it's a hypotenuse, double agent. So we're going to start with the little triangle. Leg over hypotenuse, 15 over z. And now we look at the big triangle where z is a leg and 18 is the hypotenuse. And we can solve it from there. So z times z, 15 times 18 is 270. You can't see that. 270. Now I'm going to break down 270 to its simplest square root. So I know 27, that's 27 times 10. That's 9 times 3. I think 9 is the only one that's going to come out of there. So that gives me a 3 on the outside. And I multiply all of this back together and get 30. 3 root 30 on the inside. If you're simplifying your square roots and you're just like, is that really equal to that? Just try it. What's the square root of 270? It's that. And then type in your answer. What's 3 times the square root of 30? It's that. So it is simplified. It is equal. All right. So remember, we used our rules to practice, but once you find one side, Pythagorean theorem can get you the rest. All right, let's try this one. So I'm going to start, I can't start in the middle, can I? Looky here. Because I know that 6 over y equals y over x, but I can't have two different variables in there. So let's start over here with the 9. Maybe that'll work. This looks interesting. I could. Okay, here's a couple of ways we could approach this. I could do my leg over leg, 6 over 9 equals 9 over the entire thing, which is 6 plus x. I could do that. Or, did anyone happen to think of, you can just do the Pythagorean theorem and solve for y, because I forgot about that. So that's probably the easiest approach. Let's do that. Let's say 9 squared equals 6 squared plus y squared, and we'll solve away. So 81 minus 36 is 45. That's a popular number today. I think I can find the square root of 45 because we've done it several times. So y is going to be 3 root 5. So if you wanted to, that's how you could find y. This method would work also to find x if you wanted to, or you could do 6 over 3.5, 3 root 5 equals 3 root 5 over x. So we have, once we find one side, Pythagorean theorem, we can use our similar triangle properties, any number of ways to solve. Let's do this one. Since we already know leg, hypotenuse, hypotenuse. I'm sorry, leg, hypotenuse, leg, hypotenuse. So 81 equals 36 plus x, 6x. Subtract the 36, we get 45. And 45 divided by 6, I've already got a 45 right there, is 7.5. And just to prove we would have gotten the same thing with this rule over here, I'm just going to put a big or right here. Just to prove it, leg over leg equals leg over leg. 6 over 3 root 5 equals 3 root 5 over x. So 6 times x is 6x. Guess what 3 root 5 times 3 root 5 is? You're probably thinking, could it be 45? Yes, it could. So it does give you the exact same answer. You just have to choose which one comes to your mind when you first look at it, and which one seems like the easiest thing to do, because they both work. All right, so x is 7.5. Now I can find z. So remember, there's two ways to find z. If you wanted to do the Pythagorean theorem right here to find z, you can. I'm going to use my similar triangles because I'm really trying to practice those new rules I just learned. So let's take little triangle. Remember, leg over hypotenuse. So in this little triangle, z is the hypotenuse, 7.5 is the leg. Then we go to the big triangle, z is the leg, and 13.5 is the hypotenuse. Okay, this one looks interesting. Make sure when you do this leg over hypotenuse that your second one, the hypotenuse, is all the way across. Because the first time we're just looking at the little piece of the triangle, and then this one we're looking at the big one. So z squared equals whatever 7.5 times 13.5 is, 101.25. I do not have high hopes for that being a perfect square, so we're just going to take the square root of 101.25, and it's 10.062. So I'll put my little approximately. That was the best we could do on this one because it wasn't going to be a good simplest square root. All right, so there's a lot to think about today when you have an altitude to a hypotenuse of a right triangle. We ended up with these three similar triangles. Get my little pictures. We ended up with the big triangle, the medium triangle, and the baby triangle, just like Goldilocks. And we used our similarities to find missing pieces. So if you want to separate it into three triangles every single time, you can. It's a little complicated. So I just broke it down into knowing that this segment right here is a leg in two different triangles. It's a different leg. So we said leg over leg equals leg over leg. This was the geometric mean. Then we went to our other pictures where we said, okay, this guy right here, well, in the big triangle, it's a leg. In the little triangle, see there's a right angle here, he's a hypotenuse. So this rule was leg over hypotenuse. In the little triangle, leg over hypotenuse. Then we looked at the whole thing, leg over hypotenuse. So those are the two rules you need to know to be successful with the geometric mean.